Hello, welcome back. Today, we want to talk about, as it says, the graphs of basic functions. And so our goals are to understand the properties of these basic functions, what they look like, and also how to graph them, and also their domains and ranges. So basically understand, be familiar with them, and be able to use them in the future. Let's take a look at the first, and these are not in particular order, but these are some common functions you'll see. All right, the first is called the constant function. And that's because, once again, f of x equals b. So no matter what x is, plug in any x you want, it's always going to be b, where b is some constant real number. Of course, that's true. The graph is just a horizontal line with a slope of 0. So once again, if you pick any x you want, the y is always b, whatever this y is. For example, f of x equals 3, rather, will be a constant function at y equals 3. Now, its domain, it can go forever in both directions. But interesting, its range is actually just the number b. So if you notice, this has these squiggly brackets indicating it's not an interval, it's essentially a set of just the number itself b, whatever b is. So if your graph is a function of y or f of x equals 3, your range just be that number 3. Okay, because that's the only output, is that number. Next, the identity function. So as you can see, it's the graph of a straight line. Our function is f of x equals x. Of course, it's called the identity function because whatever x you plug in, that's your output. So your output is the same as your input. That's why it's called the identity function. We can see some of the points on it. So plug in 0, you get 0. Plug in 1, you get 1. Plug in -1, you get -1. So its domain and range are both all real numbers because it goes to the left and right, any number you want, and your output could also be any number you want. So its domain and range are all both real numbers. Next, the square function. So the square function is f of x equals x squared. So whatever x is, we take it and square it. So remember, of course, anytime you square a number, it's always positive, no matter whether it starts out being positive or negative. So the examples we can see on the graph, we see it's the graph of a parabola. Examples we can see on the graph, you plug in 1, of course, you get 1. Plug in 2, 2 squared is 4. But also plug in a -1, -1 squared is 1, and -2 squared is 4. So because of this, our domain, we can plug in any number we want, is all real numbers. But since we're squaring it, since it can never be negative, our range is always 0 to infinity. Okay, so you take any number, it's not negative, because if you square a number, it's never negative. Next, the cube function. So as it sounds like, f of x equals x cubed. You plug in x and you cube it. Now, here, if you cube a number, it can be both positive or negative, depending on what it starts out with. So if x is positive, x cubed is positive, as we can see. For example, at 1, plug in 1, you get 1. And, of course, plug in 0, you also get 0. 0 cubed is 0. If you plug in a negative number, such as -1, if you cube a negative number, you also get a negative number. So you get -1. Okay. Now, those are not most revealing. So if you plug in, for example, 2, which isn't shown, 2 cubed is 8, or -2 would be -8. And here, like the squared function, our domain is all real numbers. Actually, in this case, our range, since output can be negative numbers, your range is also all real numbers. Okay. Next is the square root function. So as it sounds like, you plug in x, you take the square root of x. So here, of course, x has to be where x, of course, is a real number, and x is greater than or equal to 0. Okay, and remember, when we're working with real numbers, we can't take the square root of a negative number. And so that affects our domain. So, of course, for this graph, some of the points on this, so plug in 1, of course, the square root of 1 is 1. The square root of 4 is 2. But we can't take the square root of negative numbers. And so, in this case, our domain has to start at 0, because the square root of 0 is 0. And then it can take on any positive number. So 0 or any positive number. And for the same reason, our range, since we can only take the square roots of 0 and positive numbers, our range is also the same, 0 to infinity. Our output can be 0 or any positive number. Now, if we look at the cube function, the next function, cube root function below, then, so we plug in x, take the cube root of that. Now, unlike square roots or even roots, you can take the odd root or cube root of an even or of any number, positive or negative. So if you take the cube root of a positive number, you get a positive number. You take the cube root of a negative number, you get a negative number. So here, you take a look at some examples. So for example, take the cube root of 8, which is 2, or the cube root of negative 8, which is negative 2. So in this case, once again, our domain, we can include any numbers we want in the domain, since we can take the cube root of any number. Then our range also, because the output can be negative, it can go to any value as well. So our domain and range for the cube root function are both all real numbers. Okay, next one, this is one of the most interesting domain and range, the reciprocal function. So 1 over x, so whatever x is, then you flip it, 1 over that. Okay, so for example, if we plug in -2, reciprocal of -2 is -1/2. And also reciprocal of 1/2, you plug in 1/2 for x, you flip that and you get +2. Now here, if x is negative, if x is positive, f of x is positive, and if x is negative, f of x is negative. So we can have both positive and negative values as the graph shows. Now, since we have the x here in the denominator, then x can't be 0. We can't include 0 in the domain because that would make this undefined. So what happens at 0 is we would have a vertical asymptote. And so you think about what happens is you have 1 over x. As x gets larger in absolute value, either positive or negative, this whole thing is going to get smaller. Okay, so 1 over 10 is larger. Think about then 1 over 100, that's smaller than that. 1 over 1,000 is even smaller. That's what's happening here. So as x goes to infinity, then our graph gets closer and closer to 0. Fx gets closer and closer to 0. Similarly here, the same thing happens, except going from the negative direction. So the larger x is in absolute value in this direction, the smaller the whole thing is. It gets closer and closer to 0, but never actually reaches 0. Okay, because there's no number you can plug in for x that will actually make this 0. You can get as close as you want, will never actually become 0. And here, as we get close to 0, the opposite thing happens. So as x gets smaller and smaller, 1 over x gets larger and larger. So in a positive direction, then it goes toward infinity on this side. As it gets larger and larger, the smaller x gets. And here, it gets larger and larger at the absolute direction, but in a negative direction, the smaller x goes. So here, on this side, it goes to infinity as we get closer and closer to 0. It goes to negative infinity here as it closer and closer to 0. So our domain, as we said, we can put any number in for the domain except 0, which would make it undefined. That's the only number that does make it undefined. So our range is made up of 2 intervals, negative infinity to 0, not including 0. That's what the parentheses mean. And also 0 to infinity, not including 0. And this symbol in the middle is a union symbol, means or. That's a mathematical or. So as long as you pick a number from this interval or this interval, that's valid for the domain. It turns out our range is exactly the same thing. So as we said, there's nothing you can plug in for x. I'll actually make this 0. So actually 0 is not included in our range, but every other number is included because we can get as close to 0 as we want, either positively or negatively. We can go to either positive, get close to positive infinity or negative infinity as we want. So that's a reciprocal function. Then the last basic function is called the absolute value function. So what this is essentially is taking the identity function. Let's go back briefly and review that. We take the identity function, this function, and we simply take the absolute value. So the right-hand side on this side of 0 looks exactly the same because the absolute value of a positive number is still positive. But over here, of course, the absolute value of a negative number is negative. So for example, your input is -1. For the absolute value function, your output is now 1. So what happens graphically is this part of the graph essentially is flipped up, get the mirror image across the x-axis. Let's take a look at that. So this is the absolute value function, the absolute value of x. So once again, if x is positive, it's exactly the same as identity function. But if f is negative, and the output then becomes positive. Okay. Once again, this graph then it's flipped up. So the identity function would look like this, continue down this direction. Essentially, that part of the graph gets flipped up, reflected across the x-axis, the negative x-axis. So our domain is still all real numbers. We can plug in any number we want, but because it always has to be either 0 or positive, Our range can only be 0 to infinity with 0 included. So those are the basic functions. You want to be familiar with those and also understand their domains and ranges and be able to graph them. Thank you. Have a good day.